In this video lesson, we would like to find out an equation for the radius of an orbit in the Bohr's atomic model. We are going to use the Bohr's concepts to explain this. Bohr has proposed some points. The first point he said is the centripetal force of an electron revolving in an orbit mv square by r is the electric force between the nucleons, that is protons and the electron. So 1 by 4 pi epsilon naught is a constant where we are calling it like K. Jd is the charge of the protons inside the nucleus. E is the charge of an electron by r square is the centripetal force. That's the first concept of the Bohr's atomic model. From here we can write mv square equal to, by cancelling one radius, K Jd square divided by r. That's the one point. According to the second Bohr postulate, it is being said that angular momentum L equal to mvr, where m is the mass of the electron, v is the velocity of the electron, r is the radius of that orbit, is nh by 2 pi, where n is the principal quantum number and h is the Planck's quantum constant. From here we can write velocity of an electron is nh by 2 pi and get that mr into the denominator. Let us substitute this velocity v in this equation, in the first postulate equation, so that we'll get a derivation. That implies from the above equation mv square equal to kjd square by r. Let us substitute this v value here. M v square means nh by 2 pi mr whole square equal to kjd square by r. Let us simplify this equation further. That implies m n square h square, I'm just squaring this equation, 4 pi square m square r square equal to k jd square by r. We want to write an equation for r. We can cancel one r here, we can cancel one m here. That's it. So what is remaining? N square h square by 4 pi square mr equal to k jd square. That implies r equal to n square h square by 4 pi square m and k jd square. So by rearranging the terms, so we can say orbit of an electron in Bohr's atomic model, nth orbit, Rn can be written like h square is a constant, 4 pi square is a constant, k is 1 by 4 pi epsilon naught, that is a constant, charge of an electron is also constant, into n square is the principal quantum number, which obviously varies with respect to the quantum number. M is the mass of an electron and Z is the atomic number. So we can say, if somebody has asked a question, if it's not the electron or it's electron-like element with a different mass, the radius varies, because the radius of an electron is actually depending on the mass of that electron. So we can say, if you put a condition that if n equal to 1, principal quantum number equal to 1, Z equal to 1, that is something like a hydrogen element itself, R naught, that's the least radius that it can have, is h square by 4 pi square k square by m. These are all the, say, constant values. If you substitute the appropriate values for each one you get R0, which is called as a basic orbit or a ground level orbit, as 0.529 into 10 power minus 10, or approximately 0.53 angstrom. That's the radius of an electron in the ground state in a hydrogen atom. That implies, by substituting these values, you can write R0. All this value is nothing but equal to R0 and multiplied by automatically n square by z. Like that, for a hydrogen atom, we can get the radius of different orbits using this formula, where n is the principal quantum number and z is the atomic number. Thank you for watching. Keep coming back for more and more video lessons. Thank you.